Alright, so welcome everyone. This is the recap of the last class. Alright, so today we are looking at the Cascade controller. Alright, so what's the Cascade controller? Let's get into it. A Cascade controller is a control system configuration where two or more controllers are used in a hierarchical arrangement. Alright, with the output of the primary controller, also known as the master controller, serving as the set point for the secondary controller, also known as the slave controller. Alright, this setup allows the system to respond more quickly and accurately to disturbance by controlling an intermediate variable that directly influences the main process variable, improving stability, accuracy, and dynamic performance. Alright, so basically what we are trying to achieve here in the Cascade controller is we are trying to control, to make the set point of the primary controller, right? Primary controller, maybe the set point might be for the temperature, it might be for the flow rate, any of them. All right, making the set point of one controller, all right, to be the serving set point, all right, for another controller, like the secondary controller. All right, so basically what we're going to be looking at in this particular one is we are going to be making the set point, the master set point, to be controlling the temperature of our hot water. All right, and then we'll be making the secondary controller to be controlling the flow rate. All right, so it's going to be controlling the flow rate here, and the idea is this: the set point of this one now, you make this one as the flow rate controller here, right? It controls the flow rate of your steam into the system. Remember, the steam is serving as the heat source for your water, all right, and the heat exchanger here. So by the time the steam there's a transfer of heat from the steam to the water, that's where we're getting our hot water from. All right, that's what's happening in this particular heat exchanger. All right, so when we maintain, imagine we maintain the heat for this to be at 80 or at 75 or 70, anyone. All right, so whenever we notice that remember the set point is, let's say the set point is 80 now. All right, our set point is 80. So this temperature controller here will be sending signal to the flow rate controller here, all right, so that it's going to be regulating the flow of the steam into the system. All right, so whenever the process variable is for the, that's for the temperature, is going higher than the set point, all right, you automatically it will try and adjust the flow rate of the steam here, probably by closing the valve to reduce the flow of the steam. And then if it's below the set point, it's going to increase the opening of the valve to allow more steam to go in and then raise the heat of this section. All right, so basically that's what we are trying to achieve. So now that is a cascade controller. Remember, the set point of this is serving as the set point for this other one. All right, so basically that's it. And then your cascade controller is a multiple control system. All right, you have the single and then you have the multiple. All right, so let's get into it. Let's get into it. Let's do what we are supposed to do. All right, so ammonia palette, ammonia palette. All right, so we are making use of, I'm going to be setting up the single control and cascade control, right? So I just want us to understand how they both vary. Alright. So let's set up a single control first, alright? So this one is just basically going to be controlling the flow of your water. Alright, so I'm going to be using this to control the flow of the water. Alright, so I select water and mass fluids for water. Mass flow. That's my object, that's my process source variable, right? That's my variable source. And then I'm just going to be controlling the valve for the water, export it, and then I can decide that let's just put out here which we have one, just an assumption. And then for my flow of water, I don't want it to go below 500 and then 1.5 or at 1,500. and I decide that my set point for this should be just 1000. Alright, so that is for a single system. It's just a single process. Okay. Should be here the out. So alright, so and this particular controller is operating a reverse action. Alright, so basically what's happening is whenever the flow rate of the water increases, alright, and then we are trying to remember the set point for this particular control segment here is at 10,000. Yes, supposed to be 1,000. Right, so the set point is at 1,000, right? So what happens is this: whenever the process variable moves above it, right, and then that's the process variable for the mass flow of the water. Once it moves above the set point, alright, the control system here tries to adjust it to come back to the set point, which is the 1,000 kilometers per hour, alright. And at the same time, our range before it to send the signal that okay, there's finally a problem in this system, it has to be between 500 and 1,005. So once it goes below 500, we're supposed to set up alarms for just trying to look at the cascade and then just so, and then once it goes above this, obviously it's supposed to say alarm, but within this range it's fine. Our set point is still 1,000, right? So whenever there is an increase in the flow rates above the set point, we try to close the valve, alright, to reduce the flow. And if it's below the set point, it increases the opening of the valve. That's basically what it's doing. So it's like a reverse action, alright. So that's for this one. Okay, so let's start with the TIC, alright, which is a temperature instrumental control. Alright, so your TIC stands for temperature instrument controller. Alright, that's what your TIC stands for. Alright, so going forward, our process variable source is hot water. We are trying to hot water. And then we select temperature. Right, select temperature. And then we are saying that this particular one, let's say it's between 50 and 100. Alright, and then we're trying to maintain this at 80, let's say it's 80, right? That 80 or 75 or 70. Then this is just working in the reverse action, alright? So we are going to leave this for now because now we need to connect our HYSYS, which is the flow instrument controller. Alright, so it's just like the setup for the water controller here. It's going to do the same thing that it's going to be doing at this time, and we're using our mass flow for it. Alright, so select that as our variable source. This is variable source. Then our output this time is the world. And then now we need to put a remote set point. Now our remote set point is going to be collecting the set point signal from this. Remember what we said about the Cascade controller. Alright, so the set point for the secondary controller is the master primary controller, which is the master controller, is used to control the whole system. Alright, so select OK. You can see that it's finally connected to the TIC. Now for this, we are going to be making use of flow rates is going to be between let's see 50 50 to about 200. Alright, so let's get our set point for this to just be. Okay, so we need to tune our tune the parameters for this. Alright, so alright, okay, so for our TI, for the full controller, we have I think it's set one, and with that, goes to TLC, okay, which is going to be 1.7 for this. Alright, so this is good. Okay, so you can see set point from there it's connected to this. From this point is also affecting the valve. So remember this is your master controller and now this is your slave controller. So let's go into the dynamic mode and see how this moves. Alright, before we do that, let's open this and let's get our faceplate. Let's get our strip chart with faceplate. Alright, so let's create my strip chart. Alright, so your SP stands for set point, PV is your percent variable, OP is your output. Alright, so that's basically what this means. Okay, please strip chart, please strip chart, this yeah, this way. So I'll click this here. Let's again my faceplate to faceplate. Alright, so the idea of this faceplate is to just easily adjust your system. Alright, so if I wish to, instead of me always coming back to this point to change my set point, I can easily do that here. If I move this set point here, you can see that this is a new place. Keep it. Actually, let's do it. So I just put it. Alright, so and then you can also check your, you can be monitoring your output from here at the same time your process variable. So you can monitor it from this your faceplate. Alright, so let's get our faceplate and TI's faceplate and strip chart from FRC. Alright, let's see faceplate chart first. Faceplate. What's this? Alright, so that's pretty much ready. At the same time, you can still observe this. It's just structure for this. Alright, structure. That's good. Let's put for this. Alright, so close this. Okay, so now we can monitor the 3 control systems. Alright, controllers. Alright, so these two are the Cascade controller, right? This is the one giving the set points output signal to this for this to respond to it. And then while this one is just the single controller. All right. So let's move. Let's move to the dynamic mode now. Let's dynamic mode. Sure to switch. Yes. All right. So basically, I've switched before. That's why it just moved immediately. But normally, before you switch, it will ask you to make some changes to the system, and then you allow it to do that for you. And once it's done, you just come back to click on the dynamic mode again, and you'll be ready to do your dynamic simulation. All right. So our integrator now, from here, remember this is operating at automatic, so we are going to be changing every other phone to automatic. I think it's currently on manual. We have the starting time at 0, we have the accelerator at 1, and then the end time, we don't have a specific end time for this process, but we can put in our specific end time. Once the end time reaches, the system stops. All right. Or we can use the real time, which is the actual real time. All right. It's going to be moving minutes, seconds, and then you monitor the system. All right. So that is how it's being done. All right. So we're just going to keep it at non-stop. Watch how it moves. We're possibly manipulating the variables and then seeing how they move. All right. So let me close this. Okay. And yeah, I said we have to put all this in manual, in automatic. It's currently on manual. So I'm changing this to auto. Okay, no, this is going to be Cascade. Yeah, because it's getting the signal from here. And then I'm going to put this here auto. Alright. And then if I see for this would be auto as well. Alright. Okay. So we are ready to run the simulation and see what is happening. Let's go. Alright, so for this now, we can see that the set point for our TIC is at 80. Now the green line is the process variable. Red is your set point. The green line is your process variable. Right, so you can see that it's trying to adjust itself back to 80. First move below it, and then it's trying to adjust itself back to it. Alright, for our the Cascade control system for this, you'll notice that it's trying to alright, so this is the current flow. That's a PV. So let's do the set point, try to see how it's maintaining this. This one is transporting to convert, so just maintain it. So let's say I want to move my set points to about here. And see that going to change. So that it's actually affecting the right, but this is still trying to maintain the 80. It's a little bit below 80, so now it's 75. So it's a little bit about. So let's say I want to change my set point from 80 to about 90. So look at now let's see how this guy is going to look at this. So you can see that the fluid also changed from this to right. So this is what I'm doing. Right, so let's see for this one. See the valve opening is 100%, which let me change my setpoint for this. To do that, remember it's receiving signal from this, so I have to go back to manual and change it to let's change it to 80. So right? That's my one. And see that when we did that, stuff is coming now. I have to change it to the Cascade. See. That's just really transfer to it. Let me keep this in mind. So at this, like this, you can actually just monitor how the system is moving when everything goes to 75. Let's see how it's going to react. That's to 75. I take it below, so 60 something. And see how it moved to meet up with the 60. Right? If I take it to 80 bar, that's it. And see that it's moving to meet up with the 80. Right? How this is going. Alright, so bottom, still taking a step by step. But from all this general, you can see that it's struggling to meet up with it. It's still moving. It's still able to go up, but it's taking a lot of time. Remember, you have to also monitor the time. You have to monitor the response as well. Because if your controller is not quick to respond to the simulation which you're trying to process, definitely it will cause problems later, alright? Or if it's quick to respond to it, to every set point and all that, definitely we are going to be actually good for the system to quickly respond. Alright, so imagine a situation where it goes below the minimum and it goes above the maximum level, and then it's now taking time to set an alarm. Before it does that, definitely there's going to be a problem. So basically, your controller has to respond quickly to every information that is given to it. Alright, so basically that's how you undo a cascade control system. Alright, basically that's how you go about it. Alright, so thank you very much, and see you in next.